Looking at volume and capacity. When we're looking at volume, we're starting to look at our 3D shapes and the area that the whole 3D shape takes up as such. So we're now looking in units cubed. When we're looking at capacity, we'll be looking at the measurement of liquids and gases. Okay, so we'll be looking at milliliters and liters. But if we're looking at volume, generally we're looking at units cubed. All right, we're looking at three-dimensional shapes now. So we're looking at that length times height times width. We need 3 different dimensions when we're looking at volume and 3D shapes. Okay, so when we looked at area, we said the area was the space within the shape. Okay, we said that if we're looking at a rectangle, to find the area, we multiplied the length times the width. With our triangle, we said it was half times the base times the height, and that was because the triangle was actually half of a rectangle. We said that with our parallelograms, we had to cut the little bit off the end and put it to the other end so that we could do base times height, because a parallelogram is actually the same area as a rectangle. We looked at our rhombi and our kites, and we said that what we did was we measured the longest height measurement by the longest length measurement and multiplied them by half, because if we move those triangles around, we actually make half that shape. We looked at composite shapes, and we said to find those areas, we would have to find the area of each individual shape and then add it together. Now we need to know how to find these areas when we move on to looking at volume. We looked at our circles, and we said that the calculation to find the area of a circle was pi r squared. And in our video on circles, we really looked at how we could take the circle apart to see how that works, what pi r squared meant. Okay, so now we are moving on to volume. Now, as I said earlier, when we're looking at volume, we're talking 3D shapes, okay? And here we've got a graphic showing the names of different types of 3D shape, and we can find out the volume of any of these using mathematical calculations. All right, before we can do that, we just need to understand what a cross-section is. Now, a cross-section is when we cut through an object. In this case, we've cut through the Earth and got a cross-section of the Earth that we can look at. Here we've got a boat, and we've got cross-sections of the boat. So we've cut through the boat, okay? So understanding what a cross-section is very useful as we move into area. Because as we look at this shape, even though we've got this rectangle, what we're looking at on the front here, these front 4 units, okay, is a cross-section. Alrighty. Now, to find out the volume of a rectangular prism, we need to multiply the 3 dimensions that we've got. So the height times the width times the length, okay? So length, 3 dimensions that you've got, multiply them together. So the volume of a rectangle is length times width times height. Okay, there's your calculation, length times width times height. And if we do that calculation here, we're going 2 times 3 is 6, times 2 is 12 centimeters cubed. So that would be the volume, and we must have those units cubed on there for it to be volume. Okay, looking at cubes themselves, okay, so a cube is a shape that has all the dimensions are the same measurement. So a square has 2 sides of equal measurement. A cube now has 3 dimensions of equal measurement. Well, all dimensions are equal measurement. So if we have a look at this, we can see 3 sides. Okay, so but the volume of it, okay, it's got 3 units up, 3 units across, 3 units back. Okay, so it would be 3 times 3 times 3. Now mathematically, 3 multiplied by 3 multiplied by 3 is 3 cubed. Okay, so just remembering your cube in here. This one, you've got 2 units by 2 units by 2 units, so it's 2 cubed. okay? And this one, you've got 1 unit by 1 unit by 1 unit, so it's 1 cubed. So if we was writing these, it would be centimetres cubed, centimetres cubed. All right, so next we're looking at our cylinder here. And to find the volume of a cylinder, you need to find the area of the circle first and multiply that by the height. Okay, so to find the area of our circle, we know it's pi r squared, and then we multiply that by height. And here we've got 2 examples of what we've already looked at. Okay, so we've got our rectangle. So we're saying the volume is the area of the base times the height. Okay, so to find the area of the base, it's length times width multiplied by the height. So the volume of a rectangle is length times width times height. For our cylinder, it's saying it's base times height. Okay, to find the area of our base, we need to do pi r squared, and then we multiply that by the height. So our volume of the cylinder is pi r squared times height. Alrighty, moving on to our our triangular prisms. Here we have a triangle as our base, okay, and then we've got either the length or the height of it. Now the area of our triangle is half times base times height, and we'd multiply that by the length. Our volume would be our half times base times height, which is our area with the triangle on the end, times the length, or it could be times height. Okay, the reason we're not saying times height is because we've used height there. Okay, so we're using length. Just remember, our dimensions can be interchangeable, depends on the object we're looking at. So we've got that written there, that's what we just looked at. It can also be written like this, okay, so base times height divided by 2 times length. So that is exactly the same, it's just written in a different format. Alrighty, so when we're working with our volume, we need to remember that we may be converting from like meters cubed through to kilometers cubed. Probably more like millimeters cubed to centimeters cubed, okay? So if we're converting from millimeters to centimeters, we'd be dividing by 10 cubed. So all our conversions when we're talking of volume have to be cubed. All right, so summary. When we are finding the volume of a shape, we need to find the area of the cross section, so the initial shape on the end, multiply the area of the cross section by the height or the length of the shape, and the result is then in units cubed. And here we've got some examples of the formulas that we've looked at. Okay, now we're going to look briefly at capacity. Capacity is how much fluid or gas an object takes. It can also be in a solid form, but usually it's fluid or gases, okay? So how much can a shape hold? A container or an item that's made to hold something. The reason that I say it can be solids as well, thinking of those grain silos we were looking at, that's actually capacity. We measure the size of a grain silo in capacity. We measure the size of trucks in capacity. So that is also capacity. But here we've got some containers that have got some kind of liquid, I would say, in it. And we're looking at what capacity a container will hold. Here we've got some scientific equipment, and it's just showing different capacities. You'll see capacity is measured in a form of litres. So in this case, we're looking at millilitres. You've got your burette, your graduated cylinder, your pipette, and your flask there. Okay, so if we're converting between our units of capacity, all right, if we're moving from millilitres to litres, we'd be dividing by 1,000. If we were going from litres to millilitres, we'd be multiplying by 1,000. And that is all on volume and capacity. Now time to have a practice.